Hello friends, welcome to engineering tutorial. So we will continue our discussion related to equations of motion, and so far we have discussed about the equations of motion and their derivation using the standard method of integration, the conventional method, and the graphical analysis. Okay, the graphical method of velocity time graph. So now in this video we are going to discuss some basic concepts related to the sign convention associated with analyzing different situations related to how to assign a particular sign to motion in a particular direction, which will be particularly helpful while solving numerical problems. And also we'll discuss in a short way motion under gravity. Okay. So first, the sign convention. So it is very simple. Okay. Let's say we have this point here. We'll consider it the origin, the center point. So here we have an arrowhead to the right, then an arrowhead to the left, then an arrowhead vertically upwards, and then an arrowhead vertically downwards. So here anything to the right is considered as positive, anything upwards is considered as positive, anything to the left is considered negative, anything vertically downwards is considered negative. So here it applies to velocity, whether it is initial velocity, final velocity, whatever, then displacement, then acceleration, everything. This. Okay. Time is not, because there is no such thing as negative time. Okay, so time is not here, but the velocity, displacement, acceleration, the vector quantities we are talking about. But this thing can sometimes create confusion. Basically this is applied for the velocity and acceleration. This comes into play while determining whether the acceleration is actually supporting the motion or it is going against the motion. That's why. So I say you remember this convention, but it can sometimes create confusion. Okay, so I will use a very simple and straightforward way to help you understand how to assign sign convention. Let us say we have a situation where an object is moving in a particular direction with a particular velocity u, okay, and it is getting accelerated in that direction. Okay, its velocity is going on increasing in that direction. So here, after a time interval of t seconds, the final velocity will be initial velocity plus a into t. Okay, here plus a into t, because the velocity of the object and the acceleration, they are directed in the same direction. So here this acceleration is supporting the object in gaining more and more speed. Now let us say we change the situation where the same object, it is moving with certain initial velocity, but acceleration is in the opposite direction. There is another force which is opposing the motion and it is causing to decelerate, to slowly reduce its speed. So here, after an interval of t seconds, the final velocity will be u minus at. okay, minus at. Why? Because here this acceleration is opposing the motion. It is in the opposite direction to the velocity of the object. Here it is u minus at, here it is u plus at, here it is u minus at. So a time will come when this velocity will become 0, okay, when u becomes equal to at, it will become 0, it will finally come to rest. Okay, so always remember, if velocity and acceleration are directed in the same direction, then both of them are positive, okay, that is this kind of relationship, u plus at. And when velocity and acceleration are in the opposite direction, it gives us something like this. This will come into play when we will discuss motion under gravity, so you just wait. So this is a very simple way to understand the relationship between velocity and acceleration. Now when it comes to the negative velocity, negative displacement, negative acceleration, unless and until it is asked in the question to determine whether it is negative, positive, there is no need to assign unnecessarily these things to displacement, velocity, acceleration, because it will create a lot of confusion. I will clear it out while solving problems. Why using this sign convention can create unnecessarily a lot of confusion. Just remember this simple thing: if velocity is in the same direction as acceleration, it is supporting the motion, it is aiding the motion, it will be like this. If it is in the opposite direction, it will oppose it and finally bring the object to rest. Okay, now let us discuss the movement of an object under the influence of gravity. Okay, motion under gravity. Here you will be clear about what I am trying to say. Suppose we have an object which is at a certain height above the surface of the earth, which is much lesser than the radius of the earth. Okay, this height from ground is h and is much lesser than the radius of the earth. In that case, the object falls freely along a vertical path with constant acceleration. Okay, and that value of acceleration is called as acceleration due to gravity. Okay, and that value is equal to 9.8 meter per second square. This. Okay, so here one important thing is that air resistance is neglected. Air resistance is neglected. So here there are two important things. First, the magnitude of g is 9.8 meter per second square and its direction is vertically downwards. It is directed vertically downwards. So you can consider it as negative. In some cases it will be given minus 9.8, will write like that, but it can create a lot of confusion. No need to do that. Okay, so I will make it clear. Let us say there are two cases. Okay, there are two cases where an object at a certain height h from the surface of the earth is dropped with certain initial velocity. Okay, u. It is dropped downwards. Here we know acceleration due to gravity is acting downwards, 9.8 meter per second square. Here initial velocity is also directed downwards. Okay, the initial velocity is directed downwards. Acceleration due to gravity is also directed downwards. Here the total distance or displacement of the object along this vertical path will be equal to S, which is equal to h. If we use the conventional thing, okay, the convention, okay, downwards are negative, then here displacement S, will write it as minus h, this will write it as minus u, this will write it as minus g, okay, like this. But I say don't unnecessarily, don't create all this confusion, okay, don't, avoid it. It is not wrong, but it will create unnecessarily a lot of doubts in your mind. So simply you write it here, S is equal to h, here the total height above the surface of the earth. Here we will keep u as u, g as g, and the equation of motion will be the various equations of motion. Here the final velocity of the object just before it reaches the surface of the earth or strikes the surface of the earth, that will be equal to v is equal to u plus gt, which is derived from v is equal to u plus at. Here a is equal to g. Why g? Why plus g? Because the direction of the initial velocity and the direction of acceleration due to gravity, they are both in the same direction, downwards. So that's why this v is equal to u plus gt. Similarly, h is equal to ut plus half gt square. This is the second equation for motion under gravity, which is coming from S is equal to ut plus half at square. Okay, simply here S is equal to h. The net displacement is equal to the height above the surface of the earth from where it is dropped. Then another thing, h is equal to u plus v by 2 into t, which is coming from S is equal to u plus v by 2 into t. Same thing, okay, S is equal to h. Then v square minus u square is equal to 2gh. This is coming from v square minus u square is equal to 2as. Here a is equal to plus g, s is equal to h. And then the downward displacement during the nth second, here we will write it as h nth, okay, that is equal to u plus 2n minus 1 by 2 into g. This is coming from displacement during the nth second is equal to u plus 2n minus 1 by 2 into a. This the same thing. Here it is very simple and straightforward because the acceleration and the initial velocity, they are directed in the same direction. Now let us consider another case where an object is thrown upwards from the ground with an initial velocity u. Okay, it is thrown upwards. Here gravity is acting downwards. Initial velocity direction is directed upwards. So here the object will travel upwards. It will cover a certain displacement. It will go to up to a certain height h, and then finally it will come to rest, 0 meter per second. Why? Because the final velocity here will be equal to 0 meter per second. Here the nature of the equation will be v is equal to u minus gt. Why? Because here a is equal to minus g. Why? Because the initial velocity is directed upwards and acceleration due to gravity is directed downwards. So here this acceleration is actually opposing the upward motion. It is not supporting it, it is opposing. That's why here a is equal to minus g, and here it is v is equal to u minus at, which is coming from v is equal to u minus at, which we have discussed here earlier, this one, u plus at, u minus at. When acceleration is the opposite direction to the velocity, same thing. Same, then h is equal to ut minus half gt square, which is coming from s is equal to ut plus minus half at square, then h is equal to u plus v by 2 into t, then v square minus u square is equal to minus 2gh, then hn is equal to u minus 2n minus 1 by 2 into g. So all these equations are derived using the same. So here simply we have replaced a with minus g in the standard equations of motion. Okay, this. Okay, this. So always remember this. Whenever the direction of the velocity and direction of acceleration, they are in the same direction, then it supports the motion and we get an equation like this: u plus at. Acceleration is positive with respect to velocity. When they are in the opposite direction, acceleration is negative with respect to velocity. This. And this is demonstrated using in the motion under gravity. Okay, this is the upward motion, this is the downward motion. Okay, so we'll be solving a lot of numerical problems where these doubts will get more and more clear as we keep on solving more and more problems, so don't worry about that. Okay,